All right, I want to talk about geometric transformations, and we're going to talk about the four basic ones. So the first three are going to be related in that they're what is called a rigid transformation. It's like you pick an object up and you place it down somewhere else without distorting it. So one of those is reflection. So you can take an image, a snapshot, and then flip it across the line and place it down, and you haven't distorted anything. So if you think you take some object, there's some line of reflection, and you flip it over this. So if it's at a distance from its line of reflection, the reflection is at a distance from that line. If the line is on the edge of the object, it just rotates like a hinge, and if the line of reflection goes through the object, then it kind of rotates on that axis. The next one that we will talk about is translation. A translation just takes an object and kind of slides it. So we just push to the side this object, or we can push it down or up or to the other side. So it's just a movement with, again, no distortion. And a rotation. If we have an object and we choose some point, we can rotate around that point and our object turns. Now, again, with rotation, you can choose a point that's at a distance from the object, and so the rotation, the image, is at a distance from the object. You can choose a point on the edge of the object, so the object just spins around that point, or you can choose a point inside the object, and the object spins around that point like a vinyl record. The center of the record sits on a spindle, and that is its point of rotation. All of these three right here are rigid transformations. So the pre-image and the image for all three of these have the same angle measures between the two objects. All corresponding angles are the same, and also the side measures are all congruent between the pre-image and the image. So the pre-image is before you do the transformation, and the object after you've done the transformation is known as the image. And so we have pre-image to image. The last one, the dilation. This one's a transformation also, but it causes a change in the object. The side links are going to either increase or decrease, so it expands or contracts. And so if I take an image like a square like I've been using, and I choose a point outside, I project lines from that point through the vertices, and then if I want to expand this object, I draw lines out here that are going to be parallel to the original. So the line here runs between this line and this line, so parallel to that, I would draw this line. This segment down here will be parallel here. And so I've just kind of slid this up and expanded it. If we want to contract it, if we want to make it smaller, we again are looking to make something that's parallel, but we do it closer to this point that we projected from. And so we would do the same process. And so now I have caused the sides to contract. So these are all done with parallels. And so again, as with some of these other things that we've done, if I move this point to the interior, it affects the way that my dilation works. So if you look at this, it would project outward like this. I could put the projection point at a corner and it would project through the sides. So that's an interesting feature. So where we put this point is going to affect the way that our dilation works, just like where we put the point affects our rotation, where we put this line affects the reflection. All right, so these are our 4 basics. These involve ideas of symmetry. Symmetries allow you to move an object onto itself. And so some of these can be very symmetric. You can use the line of reflection to cause a square to reflect onto itself when you pass that line directly through the midpoint of the top and bottom of the triangle. So that's a nice symmetry. Symmetries are very important in various areas of mathematics. We can use some of these features also in whole or in part to create tessellations. A tessellation is a polygon that is copied and repeated throughout the plane and covers the entire plane without gaps and without overlaps. So I'm going to show a few examples here. This first one is an example of one that I had created for a class that I was in that I took as an undergrad. It was a geometry class intended for those who were going to teach middle school mathematics. And then I have an example of a house, and this is the roof tiling for the house, and you can see this repeated pattern that covers the roof. Now, technically there is some overlap because that's the way the roof looks, but when you look at it as a two-dimensional image, it is a tiling. And then lastly, I have this cabinet design, which makes a nice interior decor design, and it is made from repeated patterns. So as simple as a tile floor with square tiles, or maybe something more ornate like a hexagon tiling, is a very basic way of showing a tessellation. Cheerful calculations.